Okay, I guess we're going to start. Right, so the idea behind this presentation is really to talk about Java in the enterprise cloud, and specifically around some of the things that we at Oracle are doing. And I don't want this to be like just a sort of marketing talk. So my usual job is to do Java evangelism. And I like to say that I'm not a marketing person, I'm not a salesperson, I am a technical person. So I'm going to try and keep this reasonably technical, although we'll keep it at a fairly high level. As a good Oracle employee, the first slide that I have to put up is the usual safe harbor statement, which basically says that we're not committing to deliver anything on a particular date that I might say anything about during this presentation. Now, one of the interesting things about cloud computing, which has become obviously one of the real big catchphrases and marketing phrases of the last few years, is the way that Java is so relevant to cloud computing. And the reason that I find this interesting is because obviously Java is now 20 years old. We are celebrating the 20th anniversary of Java, and in fact the presentation after the break, I will be talking about 20 years of Java. But it's interesting to see how a language like this has adapted and is still very relevant to the ideas of cloud computing. And when we talk about some of the Java EE aspects of this, you'll see how the original design ideas of Java EE fit very well in terms of what cloud computing is designed to do, how you actually deploy things, how you actually want to get applications into the cloud. So the first thing that we want to do is to look at some of the basics of cloud computing in terms of what we mean by scope and scale. And really, if you look at cloud computing, it's all about the things that we already know about. It's all about enterprise computing. But rather than having your own data center where you have your machines, you have people who look after those machines, you have to provide those machines, you have to provide power for them, all those sorts of things. It's the idea that you can access these things through the network. Somebody else provides the hardware. Somebody else does the maintenance. Somebody else does the backups. Somebody else takes care of all the infrastructure for you. So where it actually is doesn't actually matter in terms of your application. We're now in such a connected world that we can take advantage of this and move away from the old style of doing things where each person has their own set of computing resources and they use that for their applications, to moving it into the cloud. And this kind of extends into the classic utility model. If you think about electricity, that's a good analogy to think about. In the early days, when electricity first started to be used in society, there were no power stations. So we couldn't just connect to the national grid. We couldn't then just plug things in. So the way that we actually went about doing that was that people would actually have their own generators. Big buildings like hospitals or offices or apartment blocks would have their own generator. And that would provide electricity to them and maybe a couple of other buildings. As electricity took off and became more popular, we moved to this idea of the utility model. So we shifted where the electricity was being generated so we could do it centrally, and then we could take advantage of the economies of scale by not having to build generators and not having to install them in individual buildings. We could move it outside the city, have one big place providing the electricity to all the houses in a town. And the advantage of that, aside from the economies of scale, are that you can then standardize things. So again, nice analogy is that we can standardize electricity, certainly in this country, on 240 volts, 50 hertz, nice big chunky rectangular pin plugs. And the same thing applies in terms of cloud computing. So we need to have this ability to standardize so that we can put our applications into the cloud and know that when we develop those applications, they will run on the platforms that are being provided. The other thing is this idea of elastic resource provisioning. And that, again, if you plug something into the electricity supply, you draw as much electricity as you need. So when you boil the kettle, you're pulling, it's about, maybe 1,000 watts, maybe 2,000 watts if you've got a really big kettle. But the idea is you only draw as much electricity as you want, and you get billed for that electricity. Same thing with cloud computing. You only get billed for the resources you use. How much storage you use, how much compute time you use, how much CPU, how much networking connectivity, and so on. It makes it a lot more economic because you can be billed simply on what you use rather than having to provision a huge data center, which you can provision based on your highest possible load, but most of the time, you're running at a much less high load. And so you're provisioning for something which is only used for a very small amount of the time. Now, the other thing I'm going to talk about here is my pet peeve of cloud computing. There are two words that get used. And premise, if you look it up in the Oxford English Dictionary, premise is a noun, it's singular. And it means a previous statement or proposition from which another is inferred or follows as a conclusion. Premises, which is a plural, means a house or building with its grounds. So when people talk about cloud as being on-premise, it makes no sense. When people talk about cloud as being on premises, it does make sense. So I will end my rant there. Now, in terms of cloud computing, we have three different service models. We talk about things in terms of the services that are being delivered to you. And you can think of this as like a sort of layered approach. We like layers in terms of computer science. At the top is software as a service. And we'll talk more about these as we go through some more of the slides. Software as a service is about provisioning applications. So you are actually interacting with an application through a web browser, through some kind of client. But you're talking directly to the application. The application is doing all the work for you. Then you've got platform as a service. And this is really, I would say, probably the most popular thing at the moment, is the idea that you are provided with a platform where you can deploy your own applications. So rather than using an application that somebody's already created, you are able to deploy an application onto that platform. And that requires the kind of platform that we deal with in terms of Java. So the Java application server is a great example of a platform, because you can take the components, your EJBs, your servlets, whatever, and deploy them into an application server, which is the platform that you're using. That, of course, gives you the whole idea of being able to take standard components and move them into that environment without having to worry about which application server is being used or what application you've got. And then at the sort of bottom of this, you've got infrastructure as a service, which is the kind of lowest level, where we're talking about how you can actually essentially have access to a machine. In the same way that you've got your laptop or you've got your desktop or your own data center, what you're dealing with is the operating system. So you've got Linux or you've got Solaris or you've got Windows, any kind of operating system. And then you can actually deploy applications or you can deploy whatever you need to do at that level. So there are three different levels that we can really talk of in terms of the cloud computing models. Now, if we look at what Oracle provides around this, as I say, I'm not going to spend too much time in the marketing side of things, but from the software as a service side of things, what I really want you to take away from this is two things. One is just the sheer number of applications that we provide through the cloud. So all of the applications that Oracle have developed over the last, goodness knows how many years, have been moved into the cloud. So you can take advantage of all the things around HR, procurement, financials, talent management, which I find a wonderful phrase, and all these different things. So we have a very broad set of applications that you can use. And these can also be very easily linked together. So if you need to have a system which provides you with HR and talent management and workforce management, it's very easy to pull these things together. The other thing that I want you to take away from this diagram is the fact that at the bottom, we have this common infrastructure and lifecycle services, and that's really a very important thing from the point of view of the Oracle Cloud. And we're going to come back and we're going to talk more about that as we go through. But as you can see, very broad set of applications available to you in terms of the things that you need. From the point of view of Oracle's platform as a service, what we've done here is to divide it up so that we cover all the main areas that people are likely to want to use in terms of a platform. So we have database, we have Java, we have mobile applications, we have the ability to have documents as a platform. So this is slightly different from the idea of the applications, but we can treat documents as a platform as well. Business intelligence, even cloud marketplace, and then developer. And I'm going to talk a little bit more about developer in some more detail later on, so we will come back to that. But again, important thing here is the common infrastructure and lifecycle services underneath that. Same infrastructure, same lifecycle services as we have with the applications, we have with the platform. If we drill into some of the platform as a service type things in a little bit more detail, if you're looking for database as a service, if you want to be able to simply create your database in the cloud and then use that as part of your application where you're simply storing your data there and you set up your tables and your various things that go with databases, then you can do that. So we can set it up in terms of either 11G-R2 or a 12C instance. So there's different versions of that you can use. You can decide how you want to deploy this. So do you want a single node, which is for lower loads and simpler kind of applications, or you can go all the way up to high availability, clustering, so you've got failover, you've got the ability to do load balancing, you've got the ability to do very high scaling and that sort of thing. The nice thing about this is that in the same way that you don't have to worry about where your electricity comes from, who actually, ensures that there's enough fuel for the power station, it's the same idea with the cloud. So we take care of all of the things in terms of your database, like backups. We provide you with a quality of service. We provide you with a contract which says that you will have uptime of, how many nines of uptime, and we can guarantee that. We will deal with making sure that your software is up to date. You don't need to have people come in and ensure that you've got the latest patches. We'll do that for you. We'll even manage the whole database management system side of things for you. What you get in terms of access is exactly what you need. So you've got all of the SQL net access. You can even get root access into your database. You can get the enterprise manager connected to that, so you can actually monitor it in the same way that you would with a local database. You can just do it through the network. And full portability, so you can either host it in our cloud or you can do on-premises rather than on-premise. Platform as a service. So what we have here is the slightly dubiously named Java as a service. And the only reason I say that it's slightly dubiously named is because what we're dealing with here is actually Java Enterprise rather than Java the platform. So we're not talking about JVM layer, we're talking about the Java Enterprise app server layer. And again, you can either use WebLogic 12c or you can use 11G. Choice is yours depending on which application you want to have there. With this, you have the ability to scale. So we have this idea of elastic computing, which means you deploy your application, and then as more people use your application and the load on the system grows, it's very easy to expand the resources that you've got dedicated to this part of the cloud so that you can make sure that there's enough resources available to handle however much of a load you have. And again, if you've got a varying load, we can move resources to and from your particular version of the application, and you only build based on what you're actually using. Once again, we take care of all the infrastructure side of things. We take care of backups. We take care of patches. We can allow you all sorts of different access. So you've got all the different ways of getting to your application code. You can go through JMX for messaging. You can do HTTP. You can even do things like RMI if you really want to. And in terms of accessing the app server, you've got root access, enterprise manager, and all of the Java tools if you want to use things like IDEs so that you can do deployments through that. All of that's available. I thought I checked every single slide here, and I've got on-premise. I really did think I checked every single slide. Anyway, so let's talk a little bit about Java and Java EE and the design principles, how they relate to platform as a service. What we've got here is very much the ideas that Java Enterprise has had all the way from the beginning. And if you think about the sort of approach that we took in the very early days with Enterprise Java, it was about allowing you to develop components that could be deployed and linked together, but without having them all having to exist in the same place. You had the idea of your sort of client layer. So you had servlets. You have the idea of things like session beans. You have the idea of entity beans, which allow you to then map into the database. Now, obviously, things have changed over time, so now you've got the Java persistence architecture, which gives you a slightly different way of mapping from the database into the objects that you have in your application server. But the fundamental ideas are still the same. What you want to be able to do is take these components, and this also kind of ties in with what's become very popular over the last couple of years, which is microservices. Because essentially what you're doing by developing individual EJBs, by developing individual servlets, is developing things that can be, if you wanted to, deployed into a microservice. But what we're doing at this point is using the application server. But where that application server is doesn't matter, because when you connect different components together, you're using things like JNDI, using the naming and directory interface, so you can locate where those services are coming from. And that way, you can have one particular part of your application running in one application server. You could have another part of your application running in a different application server. And by using JNDI to locate where they are, you can link them in whatever way you want. And that, again, fits in very nicely with the whole idea of cloud. Because all you're interested in is once you deploy your application is that it's happening somewhere and you can access it. But what actually happens in terms of the implementation, where the cloud service provider puts that, all of that can be handled because you can break it up very nicely into these individual components and have them distributed in whatever way you want. With more of the advances in terms of Java EE over sort of the last few years, a little bit more than the last few years, but the idea around using dependency injection, inversion of control, so that we can have the idea of annotations that simply inject a resource at a particular point, that again really suits the whole idea of cloud computing, because we can actually say, right, this database is coming from there. We can change the IP address, or we can change where it's coming from very easily without having to modify the code. Same with when it comes to defining an EJB. You can specify certain attributes of that so that you're injecting those values at runtime, and that can be changed without having to modify the code. So a lot of this is really, cloud computing and Java EE really fits together very, very nicely. What we have done is to look at what cloud computing does in sort of taking it a little bit further and saying, right, what can we do with Java EE that will add more features to make it fit even better in terms of cloud computing? So, in terms of Java EE, we place a lot of emphasis on the idea of roles for who does what in terms of the application lifecycle. So you've got somebody who develops, you've got somebody who deploys, you've got somebody who administers, that type of thing. And what we've done is to enhance that whole idea so that we can address the needs of platform as a service. We can have new roles that are identified specifically for a cloud. We can have services as first-class citizens. We can also have the idea of multi-tenancy. If you want to have a cloud, and from a cloud service provider's perspective, you might want to have several different clients all using the same, effectively, piece of hardware. But they need to be isolated because you wouldn't want to have competing companies able to access the application code or the data of one another. So multi-tenancy is all about making sure that you're very, very tightly isolated from other applications. And that's the kind of thing that we've been looking at in terms of Java EE and making sure that you can run multiple applications in the same application server without having interference or the ability to even do things like snooping, IP traffic, that sort of thing. So the key thing here is it's all about evolution, not revolution. Java EE already has a lot of these ideas based in it. What we're doing is just extending it to make it fit even better into the idea of cloud computing. Again, looking at some of the other services that we have, there's developer as a service, on a platform as a service. I'm not going to talk about that now because I'm going to go into that in a bit more detail in a moment. Mobile, obviously, the way that things have shifted is that now pretty much everything is done in terms of mobile computing. We all use tablets, we all use mobile phones, we all use laptops. So the ability to actually provide the data from your cloud into a mobile client is absolutely vital. The ability to have iOS clients, the ability to have Android clients, and so on. The ability to have push and notifications available from this so that you can have your application running and rather than having to poll for data, you can actually push data down to a particular client. So that's covered by the Oracle Mobile Cloud Service. I mentioned the idea of documents, so we can have a platform that allows you to have document sharing. You've got the idea of team workspaces where you can share documents. You've got the whole idea of tying that into the mobile space, but also web, desktop, offline access, all of the things that you would want in terms of sharing documents. And synchronization, because that, of course, is something that's very important. If you've got more than one person working on the same document, you want to have ways of synchronizing that data and identifying where there are changes that might be overlapping or change. Business intelligence, very important. So what we want to be able to do here is provide key performance indicators based on what's happening in applications. We want to be able to build reports based on our application data, what we're gathering, that sort of thing, create dashboards so that we can see a summary of the data in a very easy to understand way. And again, looking at different types of clients from that for web, for mobile, and Office. If we move down into the sort of the bottom level in terms of what Oracle can offer from the cloud, and we talk about infrastructure as a service, primarily people think of this as being like storage and compute. So how much storage space do you get? How much computing resources have you got? But we kind of take this a little bit further. So we've got the idea of caching. So you can do in-memory caching of data to improve performance. We've also got some of the sort of things that sit around that. So like security and identity administration, the ability to do messaging into the application through the infrastructure, and also synchronization of data. So documents, as I said, and other types of data can be synchronized through this. And once again, the important thing here is having common infrastructure, common lifecycle services underneath even the infrastructure as a service. If we look at a little bit more detail at some of these things, essentially what we've got here is on the left-hand side, we've got the idea of storage, elastic storage, so that you can expand depending on what you need for your application. We've got things like we're using OpenStack and Swift, which is the object storage API that's being developed there. You've got the ability to do restore management, so taking backups and then being able to do restores from them. Gateway from our cloud into other types of network attached storage or things like that. And then you've got even tying into things like archiving and this wonderfully named glacial quality of service, which is more kind of related to the Amazon Glacier type of backup storage. So if you're looking at data which you want to hold for a very long time, but you're not looking to access it very frequently, so if you're looking for long-term backups that you might only want to very, very occasionally need for some restore, then that's the kind of thing which can be very good, because we can kind of push it into a tape store, and then it's very low cost for you, and if you want the data back, obviously it's going to take us a while to pull it back from tape rather than going to a disk and bringing it back from there. On the compute side, obviously we've got the usual things here in terms of elastic network connectivity, elastic compute resources, which means that you can ramp up or ramp down the number of processors that are being used, number of network connections available. That ties into the storage side of things. It also requires a lot of detail from us in terms of resource management. We need to be able to determine, how much you're using in terms of the compute resources, how much you're using in terms of storage, so that we can bill you accordingly. Orchestration, metering, quotas, these are all sort of higher-level functions that we need to be able to deal with in order to give you the best possible service, so that you can decide how you want these things to work, how you want to adjust the level of service that's being provided, the number of resources, and so on. All of that in terms of determining your quota, determining the way things are metered, and how you actually use these things are available through a RESTful API. So we look at the common infrastructure and lifecycle services that we've talked about a lot, then what we're talking about is these different things. Diagnostics. If something's not working the way that you want it to, how do you find out why? And this is often the case, is that you deploy an application, something's not working quite the right way. How do you find out what's actually going on? So the idea of having logging, the idea of notifications if certain events happen, then that's all built into the common infrastructure. Deployment. How do you get your application from your development machine into the cloud? This is quite a complex, or can be quite a complex thing. What we try to do there is to make it as simple as possible. How do you install your application? How do you go about doing upgrades? How do you go about doing patching of an application? Once the application's up and running, how do you deal with monitoring it? If you want to know, is the application responding well to your users? Is there something which is preventing it from doing what it needs to do? You need to be able to monitor it. You need to have the ability to plug in things like an enterprise manager to the application, to the cloud, in order to find out what's going on. How do we deal with provisioning? We need to support that kind of thing. So if you want to come to us and say, right, I want to use your cloud, I want to be able to deploy my application, I need it to be able to support a certain number of users as a minimum, I need to be able to support a certain number of users as a potential maximum. All of these things need to be specified through the interface that we provide for provisioning. How do you migrate? If you want to move applications you already have in your data center and move them into the cloud, we can provide you with ways of migrating your application into the cloud and doing it in as seamless a way as possible. And then from the developer side, continuous integration and delivery. And this is something we'll talk about in a moment. But this whole hot topic of how do you reduce the amount of time to get your changes into the application in terms of production so that people can use it and get advantage of these things as quickly as possible. Just to give you an idea of the scale of the Oracle Cloud, this is, these numbers are a little bit out of date now. They're several months old. Yeah, can you believe? Months old. It's incredible. But we have 19 Tier 4 data centers. That was another lovely marketing term that I heard the other day. It was an embassy-grade data center. I don't even know what that means. We have over 30,000 devices, 400 plus petabytes of storage available. So there's plenty of ability to support lots and lots of users and lots of applications. We're talking about, over 23 billion transactions a day, 62 million users a day, and like I say, these numbers are out of date already. Let's talk a bit about developers, because this is a developer conference. So let's see what we're doing in terms of development for the cloud. There are really two big areas where developing applications face challenges. First of those is cost. If you want to set up a team to develop an application, you obviously need certain things to do that. So you need hardware, you need software, you need machines for your developers, you need the right tools for those developers. Once you've decided what those are, you've got to install them, you've got to set them up, you've got to maintain them. You've got to connect all your components. You've got to configure the IDEs to take advantage of whatever database, whatever enterprise systems you're going to be using. And then you've got to make sure that you maintain and you upgrade the versions of those. And then you've got to connect it all to the deployment platform. So cost-wise, that's a lot of challenges. But then there's also the idea of the process. How do you go about developing applications in the best possible way so that you can make changes rapidly? How you can react to the needs of your users, the needs of the market, in as quick a way as possible. This is where Agile comes in. How do you respond in an Agile way? So lots of different things there. So the agility that you have in terms of being able to address the needs of your users, being able to produce better applications. How can you reduce the number of defects in the code that you're producing? So things like code reviews, things like working together in teams effectively. Streamlining deployment, making it as simple as possible to get your application into the cloud. And then managing those teams and developers. So how do you go about tracking what's going on? How do you track number of bugs? How do you track what's actually being developed, what features are being addressed, and so on? Teams nowadays are more and more working remotely from one another, so they can be distributed over a large geographical region. So how do you do collaboration? How do you do team communication? How do you prioritize all of these things? So there's lots of different issues in terms of process. And this is where kind of DevOps really kind of comes into this. And this is the new sort of, relatively new kind of idea of merging development and operations. So it's not two separate things. And somebody had a lovely picture that I saw the other day where they were it showed a soldier throwing a grenade. And it was the idea that this is developers who are giving the code to the admins. And it's basically, development's complete, ship it. Give it to admin's responsibility now. That's changed. We're now in the idea of continuous integration. We're doing manual testing, manual delivery. That's what we need to move away from, because in terms of manual testing, manual delivery, we need to sort of automate things to simplify the whole process. And this is what we end up with, is now continuous integration, continuous testing, continuous delivery. Developers work together. They know what they're working on. They develop the code. They push that into a source code repository. That gets built automatically. There's no more having to do that manually. I'm just going to share a little story here with you, because when I've been looking at this kind of thing, it's, as somebody who's been in the IT industry for several decades now, I remember in my first job, we worked as a team and we had to develop code. And back in those days, integration and build environments was basically typing the command make. So who remembers make files? Yes, everybody, hopefully. Okay, so we had a system, because when we were developing the code, we would all develop individual components, and then we only wanted to do a build when everybody had completed their components. So we were sort of sitting around in this open plan office, and we had a table in the middle of us, and each of us had a make card. And then when you completed your bit of work, you put the card in the middle. The last person who put the make card in the middle then actually ran the make. And that was our idea of continuous integration. Things have moved on since then. So we do have continuous integration. We push into a repository, that gets built automatically. That can get pushed into a package repository. We can push it into testing so that the testing can be run automatically in terms of acceptance testing, functional testing, and integration testing. And then that gets pushed out into the production environment where we can, actually have monitoring of performance. We can have monitoring of how the system's running. So this is much more the sort of modern approach. And that fits in very well with the idea of the cloud. So the developer cloud, in terms of what Oracle is doing, is all about bringing this all together. So from the developer's perspective, you commit into the developer service. So you have your IDE, you work on your code, you commit into it. There's all the things you would expect to be able to handle there. So you've got things like wikis, so you can have team communication. You've got things like task lists, so you know what's going on. Source code repository, you've got Hudson for doing the continuous integration and build. You've got the ability to do review. That then can get pushed automatically, deployed into the Java Cloud Service, cloud or on-premises. And then you can sort of track and monitor what's going on in terms of the individual developers. There are a number of different interfaces that you can use for the developer cloud service. So you can use your favorite IDE, you can use JDeveloper, you can use NetBeans, you can use Eclipse. There's dashboards that you can access through the web. You've got the ability to do RESTful interfaces. So if you want to actually control things, you can do that through a RESTful interface. You can even do SSH into the Git. There's Mylin for Eclipse task management type of things, and the ability to integrate partners into this as well. From a functionality perspective, what we give you is the ability to do exactly what you would expect to do from a developer point of view. You can manage your projects. You can version your code, and we specifically use Git for that. That is pretty much the most popular one at the moment. So Git makes sense. You can version your code with that. You can review peer code. So again, the idea of being able to look at the quality of your code and have people review different people's code to make sure that there's no errors there. Tracking project issues, automating project builds through continuous integration with Hudson, and again, sharing information through wikis. We have a couple of special features around the Oracle platform. So in terms of the Oracle Developer Cloud Service, clearly it's tied into the Oracle Cloud Services. So things like WebLogic is the way that we deploy enterprise applications. We use the ADF libraries for the mobile side of things. We use JDeveloper deployment profiles if you want to use JDeveloper. And then, as I said, there's integration with different IDEs. So there's the Oracle Enterprise Pack for Eclipse, and there's also integration for both NetBeans and JDeveloper. The idea behind this is to make life as simple as possible for you. So what we've done is to make sure that the deployment is as seamless as possible. You simply compile your code, you put it in Hudson, does the build, and you can actually get it to automatically push it into the cloud. Central management console, so you can see what's going on, and support for the software as a service extensions. So if you want to tie into some of the application code, that's there as well. Now, one of the things I wanted to talk about is the way that we use our own products to build our products, because this is always a good way both to test the fact that our code works, but also to show people that the systems that we're using mean that if you're using them as well, they will work to do what you want them to do. So if we look at specifically the Developer Cloud Service team, they have a distributed team, so they're based in several different places around the world. They've got over 145 developers, and they are dealing with, well, I should hope it's thousands of lines of code. What they use is an Agile methodology. So they use scrums every 2 weeks, and they have these sprints where they set up, okay, what they're going to do for the next 2 weeks, and then they obviously sprint towards that. And then they use the cloud developer services themselves to manage all of the developer operations. It's almost kind of like a recursive thing. You're developing the code that you're actually using to develop the code. In terms of source management, they've got 27 Git repositories, which makes up one particular project. Now, the way that works is that obviously by breaking it up into 27 different repositories, they can have different pieces of work allocated to different parts of the project. Even though the project encompasses all 27, it's easier to divide it up into smaller repositories, so you're only working on something which is specific to the area that you're focusing on. You can then obviously version those and branch them independently. So if you've got one particular bit that you want to change and you want to branch that off, then you can do that without having to affect the rest of it. Build process uses Hudson, so you can do check-in builds if you want, but then there's also a sort of rolling build where twice a day they'll do an integration build all of the repositories, make sure that everything is actually done, deploy it into a virtual machine in the cloud, check that everything through functional testing is working, uses Selenium for that. And then every 2 weeks, it'll do like a production build and promote that so that people can then do testing specifically on that. Again, being pushed out into the Oracle Cloud in a virtual machine, doing QA against that to make sure that all the changes that have been made reflect what's required and also don't break anything. And then if all the tests pass, then you can actually deploy it out into the customer production environment. Metrics overview, lots of different features, lots of different branches involved, so that it's quite a complicated system. Like I say, 2 integration builds a day, 2-week development sprints with 1 automated production release every 2 weeks, assuming that all the tests pass. And we're looking at over 1,000 transactions a day. That's in terms of updates to code, over 1,000 changes to code a day. So it's quite a heavy usage. And the great thing is that it all works. And in terms of our own IT systems, it is actually quite scary, the number of systems that sit behind Oracle. So there's 602 Exadata systems, so that's the sort of engineered database systems. There's 383 Exalogics, which are running the app server. We've got nearly 70,000 Sun x86 servers. We've got nearly 7,000 Spark servers, nearly 2,000 ZFS appliances, and thousands of other machines. That supports 924 Oracle products for 135,000 employees. And I can actually say from experience that this actually works. And I personally find this quite surprising, not because I don't trust the fact that Oracle do work, but I'm kind of like an IT sort of pessimist. I always assume things are not going to work rather than actually work. And so the fact that we have all of this technology and the downtime that we have for our applications is really almost none. I mean, it's literally down to sort of controlled availability where people want to actually install a new app, then it might be a little bit of downtime. Most of them really don't see any downtime in this system. And the response time is also very good. One of the things that we did as well, this is more kind of an eye chart really, but what this is to sort of highlight is the way that we changed the way we did things in terms of our IT system internally based on looking at how the cloud works and what we could do with the cloud ourselves. So in terms of system administration for servers, storage devices, and the amount of storage that each admin was working on, we've basically increased it by over a factor of 2 in every area. So 2.2, 2.8, and 3.6 for all these different things. So that means we're controlling far more resources from the same number of administrators. And how we did that was not simply by using faster machines and doing a few things differently. It required changes in several different areas. One was actually like a cultural change to make sure that people understood how we wanted to approach these things. Using our own cloud, so using platform as a service, using infrastructure as a service, as a way of delivering these things into our own organization. And then tying this in with things like Chef, with Puppet, all sorts of other technologies for how we could automate a lot of these processes to minimize the amount of effort it requires to do these sorts of things. So just to summarize, basically, the idea of the Oracle Cloud is it's scaling to your needs. So from the software as a service side of things, you've got a complete suite of modern integrated applications, very broad, very integrated, the ability to select which bits you need. Platform as a service allows you to build your applications, allows you to extend, scale to what you need in terms of things like Java, application servers, and so on. And then if you're looking at infrastructure as a service, storage solutions, compute, all elastic provisioning, agile, responsive, exactly what you need. And then underneath, as I said, common infrastructure, lifecycle services. So regardless of whether you're using infrastructure, platform, or software as a service, it's the same set of infrastructure and lifecycle services underneath. If you want to get started with this, cloud.oracle.com/developer service is the place to go. There's all sorts of information there. There's videos, there's white papers, documentations. You can sign up and you can try these things out. And what I would also recommend is going to the Oracle booth and learning a bit more about these things and how you can get involved in some of this development, because there's also a chance to win an Apple Watch. We actually have one. I don't think it's the most expensive one. I think it might be one of the sort of like the lower end models, but it's still an Apple Watch. And with that, I guess I've got time. Yes, I have actually got time for a few questions. I don't know if anyone's got any questions. Stunned silence. No hands. Okay, well, thank you very much.